center, the industry in Belgium. And together with two companies, Altachem and Flagstone, I will present today this webinar. On the menu for today, we have for you to start an appetizer. I will explain you why you are actually attending this webinar. I will frame our project in a little bit a bigger frame. Next, after that, we will present you as a starter why Altachem is doing this project, and that will be presented by Laurens. Then as the main course, the hardware solutions that we have been developing will be presented by my colleague Peter. And as a dessert, for me, the most important part of the menu, the software solutions will be presented by Flagstone. Joris of Flagstone will do that. So with the copy, we will present you what are the next steps. And in the end, you can ask some questions and we will try to give you the necessary answers. So let's start with the first topic, why you are attending this webinar. The fact that you are with us here today in this webinar probably means that the challenges we are showing here are not strange to you or are quite familiar to you. And then I'm talking about smaller batches and shorter lead times that are ever becoming smaller and shorter, leading to an increased complexity in production. And then I'm talking about more changeovers, the paperwork that increases because it comes with every order. It is more batches in shorter times and so on. And the general answer that you read in newspapers and articles is then we have to be more agile, we have to do smart manufacturing, we have to look to Industry 4.0 solutions and so on. And very often, companies look then to the production processes. They look how they can make these production processes leaner, faster, more efficient by applying automation solutions, installing robots, connecting them to a network and making dashboards and so on. And of course that is important, agreed, but it's not what we will be talking about today. Today we will be talking about the processes that link these different production steps to one another. Today we will talk about logistics in production, we call it. And when we look at figures and see that sometimes more than 50% of the time that an operator spends is on logistical tasks, it means to us, we are convinced that there is still a big opportunity to improve for companies in this production logistics domain. So that's why we decided to do this project. Now, when you start with production logistics, there are always three domains, three areas to consider. Operations technology, the hardware, information technology, IT, the software. And you will see that in the coming 50 minutes, that will be the major part of what we will be discussing. But to be clear, it is actually the operations management, the way you organize your production, that's actually where it all starts. So to be clear, the situation at the company that is involved in this project at Altachem, they had already a very good installed production organization. So if in your company it is not really the case yet, it's really worthwhile to look first at the organization and then only look at the OT and the IT to add them to this good organization. When we zoom in then a little bit on the specific project that we want to present you today, at Sirris we always look we always want to make the vision of Industry 4.0 a reality. So we call it 4.0 made real. And also this project frames in this willingness to make the 4.0 vision real. The key players in our story today will be the AMRs and the AGVs. So the autonomous guided vehicles or the automated mobile robots. We will try to make them real in this project. And these mobile robots, they, of course, they allow logistical automation, but still there are a number of challenges with them. And I listed the 3 of them that we are tackling in this project. The loading and unloading is not always, if it's easy, it's maybe not fast. So the speed is quite an issue we see very often. And also when to follow up the tasks they need to perform, it's not always easy to manage and to manage them. And that's what we call orchestration, the orchestration of the task of the AGVs and the AMRs. And if on top of that, you install different brands of AGVs, of mobile robots on the same production floor, that orchestration becomes even more difficult. And we want to make things practical. You will see that we have that we will do things in a real production environment. So Altachem, one of the 3 partners in this consortium, we will be doing this project on their production floor. The software, the orchestration service, will be developed by Flagstone, and the loading and unloading concepts and ideas will be developed by Sirris, or are developed by Sirris. So that makes us a consortium of 3 partners, and actually we are very proud today to present to you the work in progress that we are making. When we were sitting together in the beginning with the 3 of us, the goal of the project was quite clear. We needed to improve production logistics. But next to that, because it's a quite high level, we also decided to add a subset of other goals. And you can see them here. We needed these production logistics to be task-driven. More explanations about this will follow. We needed to focus to reduce the logistical tasks of operators, and so that we can replace them by added value tasks, and we will do that by deploying AMRs in the end. But still, the operators, we wanted them to stay into control of the system, of the production system. We also wanted that new product variants could easily be added to the system without a lot of hassle. And the last point, we needed to free up floor space so that on the same floor space available in the factory, an additional machine or maybe 2 could be added without having to elaborate or make the production plant big. So that's the starting point. That's what we are working towards. A part of this project is financed by the Trinity framework. Trinity is a European Horizon 2020 project, and a part of their activities is to organize calls for projects. And in their first call, we as a team have submitted a project proposal together with 125 other teams that submitted a proposal. And actually, we are quite proud that we have been selected together with 18 other teams to have our project selected to also bring it to a reality. Then I will conclude with the status of the project today. As said, Flagstone has been building the software building blocks. Sirris has been building the hardware building blocks. We have been integrating them in a lab environment at Sirris, and that's where we are today. So that's also what you will see today. The video that you will see, they will not be yet on a production floor. They will be in a lab environment, but we will be working in the coming months to bring them to the shop floor at the company Altachem. So that concludes the appetizer of the menu. I will now pass the floor to Laurens of Altachem, who will bring you the first dish and explain about the use case of this project. Laurens, the floor is yours.
Okay. So hello everyone, I am Laurens van Goobergen, process engineer at Altachem, and I will tell you something more about our specific case. So Altachem produces valves for construction foam, as you see here, but we also do foam guns and caulking guns, and also accessories for the foam cans. In terms of people, we are a rather small company. We have 23 people on board. But we also have our own R&D department on site who designs the valves, the guns, the accessories. But today we're going to focus more on the valves and the production specifically. We're also part of a bigger group, the Lindahl Group, which is more active in aerosol. So think about deodorants, dispensing technologies, and pharmaceutical applications. But as said, today we are going to focus more on the valves. So this is our production area for the assembly of the valves. So we have 3 machines, first machine, here a second machine, and a third machine here on the left. And on the bottom left side, you see an example of such a valve. It's made out of 3 components: the white part, then the black part, and then the metal ring around it. So those are assembled on the 3 machines. But first, let me tell you something more about our digitalization and the way we are striving to work more efficient. And that's all. That's why we also implemented some digital tools. The first one is our OEE dashboard. This is also visible in the production hall. So the operators have a real-time view on the efficiency of the machines. They can also see the machine stops, so they can interact really fast. A second tool that we have is our production dashboard. Here the operators can process running orders and also do the necessary entries. We also have our SharePoint platform where operators can take a look at the digital work instructions, make reports, check the agenda, and find general announcements. And also, as of the beginning of this year, we integrated an AGV. This one is able to support our operators and our warehouse clerk by helping in the intralogistics. So the AGV is used for inbound movement, supplying the machines with components, storing finished goods in the warehouse racks, and also doing the outbound movement. The operators can use it on the same digital screen as mentioned before, and they can just ask the AGV to pick some pallets and bring them closer to the machines. Now I would like to tell you something more about our current way of working. So again, this is a picture of our production hall, and we have 3 machines here. And at the moment, so an operator or the AGV will pick some pallets out of the racks and bring them closer to the machine. So that's basically supplying the machines with components. Then it's up to the operator to supply the machines with the components on the highlighted locations. I can show this with a small video. So by using a vacuum lifter, the operator will pick the boxes and empty them into the machine. So he opens the boxes and then he empties them into the bunker. And he will do that for all the stations on the machines. So now he'll go to the other position and do the same. So this is the first step, so supplying the machines with components. And in the second step, he also needs to make boxes and bring them closer to the machines. So here he's operating a box erector. He puts a bag into the boxes. And then when that's done, he will put them on the machine.
Lawrence, we can't see that movie. Eh?
No, wait. Can you see it now?
Yes.
Okay, my apologies. So the operator will put it back into the boxes, and then he'll put them on the machine, and he'll do it for all three of the machines. So he's doing that here on the highlighted area. And but then when the machine has assembled the valves and put them into the box, it's up to the operator again to finalize the process. And he's doing that by shaking the box, closing the back, closing the lids, taping it, and then palletizing it. The same principle. He's using a vacuum lifter to pick the boxes and palletize them. So that's basically the current way of working. So we have at the moment a decentralized system where all the pallets are put next to the machine and all tasks are individual per machine. So when you look at this in an action diagram, we can see that the operators need to walk around a lot. And this is only for the 2 machines, not for the 3 machines. And if we make a division based on the time they spent on all the actions, we can see that 25% of the time is spent on supplying the components. 25% of time is spent on making boxes and putting them next to the machine. 23% is spent on palletizing, and 22% is only spent on just walking around from a certain action to another action. And then the 5% are other things such as machine interventions and so forth. So our operators do around 17,000 steps in a shift. So they need to walk around a lot. And yeah, we do not feel like this is the way to go for the future if we have more machines and want to work more efficient. So in the end, our problem and the case that we are working on is to be future proof. So if we have the 3 machines or even more machines in the future, will this still be a good way of working? We also want to focus on efficiency and increase productivity without increasing the workload. So it's hard for an operator to operate all the 3 machines. And if there will be more machines in the future, yeah, it's not feasible to continue this way of working. You can also see we have a vacuum lifter for every machine. Should we still do it in the future or not? Well, with this way of working, we should, but yeah. So it would be nicer to have a centralized way of working, meaning that we should not have all the pallets near the machines and palletizing here, palletizing there. So having a centralized system where we have one zone to depalletize and one zone to palletize would be better. We also still want all the tasks to be human-centered, so that the operator is still in control of what's happening and that he still has a grip on the production. And also, if we do the changes, we want to limit the impact on the current equipment. It cannot be the goal to change the machines in such a way that it's even harder than before. And now I'll leave it up to Peter to talk more about the solution.
Thank you, Lawrence. Good morning, everyone. My name is Peter Paulsen, Senior Engineer at Sirris. And together with Stijn and Philippe Vincent, we are working on this Trinity project from Sirris side. One moment, yeah. Today I would like to show you our results of the project till now. The topics that I would like to mention are the goal of the project, Lawrence already told you the case, but I want to summarize some things. The concepts that we have developed, the economic feasibility, very important. Is it possible or not? The chosen AMR types and the communication between different brands of AMRs. And in the end, I will show you a short movie of our demonstrator in our lab in Sirris. And at the end, some very short next steps. As you already heard from Lawrence, the goal of this project in terms of shop floor layout is to limit as such as possible the width, the pallets around the machines. So we want to avoid that. And also we want to minimize the pallet movements in production because they want to create room for additional machines in the future. Also, they want to avoid duplication of tools, because when you put a new machine in the current production shop now, you need on each machine a vacuum lifter and also extra packaging. You have to duplicate them, but you want to avoid that. How can you arrange that? By working with a preparation zone, like you can see here in the picture. So a zone decoupled from the production, but located close to your warehouse and to your machines. What about material replenishment? We want also to avoid non-value adding manipulation from the operator, such as transport components to the bunker and unload them, transport empty boxes to the machines, pack and transport final products also in boxes to the outbound zone. How you can do that? Make use of AMRs in combination with Karakuri Kaizen systems. So transfer components, parts with minimal operation interventions, like you can see here in the movie. So we started with these challenges and came to the following concepts. First of all, for the component replenishment, in the preparation zone, the operator can prepare the required components. This is where we came up with a dedicated carrier, where the operator can drop 2 or 3 boxes with components into that carrier. And as you can see in the movie, a Karakuri Kaizen system will fill the bunkers without operator interventions. And this carrier can be picked up by an AMR to do the transport from the preparation zone to the bunkers. What about the empty and full boxes? We were looking for a solution to transport these boxes to the machine and to the outbound zone. We came up with a concept with an AMR with a driven conveyor on top of it. It is also important in the PLC of this conveyor that we want to set speed, turn-off times, waiting times, and so on, because it is important. There is a difference between an empty and a full box. Of course, the height is also important, the height of the conveyor. This is depending on the existing conveyors at the assembly machines at Altegem, and also of the top box taping machine at the end. So in this case, the height of the conveyor is 660 millimeters. So as a concept, we need AMRs to transport carriers and boxes. But what about the economic feasibility? Is it possible or not? 2 important questions are: how many FTE are needed in the preparation zone to prepare 2 machines? And how many AMRs are needed for transport? First of all, the operator occupancy. To get a quick and first impression of the feasibility, we have used a simple Excel sheet and no expensive simulation software. With Excel, you can already get a good first impression of your needs. We did that by means of observations in production, videos, and proof of concept test, and so on. So when you, like you can see here in the picture, one operator should operate 2 machines. His occupancy is 42%. So he still has enough time for preparing other materials or throw away waste and so on. What about the AMR occupancy? Here we proceed in the same way. As you can see, we should need 2 AMRs. One AMR for transport of carrier with components, and one AMR for transport of boxes, the empty and the full boxes. So conclusion, it's possible. For this demonstrator, we have chosen the following AMRs. Namely, for the transport of the carrier, we choose the Wewo. This AMR has a payload of 200 kilo and a lift on board. With that lift, he can pick up the carrier. See also in the picture. We use a universal substructure, where in this case, we further build up the carrier with pipe and joint materials. The advantage of this black substructure is that it can be used for different applications. So you build up what you need. To transport the boxes, we chose the MIR 200. The AMR, or this AMR, has also a payload of 200 kilo, and we built on top a conveyor. What about the communication and sending orders to the AMRs? Each AMR has its own software user interface to create maps and missions. Both AMRs work on the principle of SLAM, simultaneous localization and mapping. What's the meaning of that? We let the AMRs drive around in their new environment, and the map will be created by natural orientation points in your production. So you don't need to place extra landmarks. You can create your map with natural points in your production, like your machines or walls and so on. And the AMR can localize itself then afterwards into that map. For the Wewo, we have to install the Navitec system software. You can see it on the left side. And with this software, you can create your maps and missions. On the other side, the MIR has a web server on board, so that you can only have to surf via a web browser to the IP address of the MIR to see this interface, like you can see in the picture. With those platforms, you can create your missions on both AMRs. But to send orders to the AMRs via the orchestration platform of Flagstone, we have set up a REST API for both AMRs. So you need a REST API when you want to send orders to different brands of AMRs. About the orchestration software, Joris will tell you more in the next presentation. In the following video, we show you our results till now in our lab in Diepenbeek. This is my colleague Philippe. He is simulating an operator at the assembly machines of Altachem. He's going to request components for the bunkers via the orchestration platform of Flagstone. Also, the request for empty boxes and full boxes can be done with this interface. This order is then sent to the preparation zone, where Philippe is again the operator. He starts this order there and fills the carrier. After filling, he closes this order so Flagstone can start the Wewo. The Wewo lifts the carrier up and starts driving to the bunker. Here you can see the Wewo software environment. By a Karakuri-Kaizen system, this carrier is emptied at the bunker. So Wewo will dock at the bunker, and with that Karakuri-Kaizen system, the components can fall down into the bunker. and afterwards the wheel will drive back to the preparation zone. Here you can see what the safety scanners detect of the environment when driving. These scanners are also used for safety and will in this case stop the AMR when an obstacle or person is detected. The charging of the battery can also happen automatically with this charging station. So till now the components, then the boxes. The MIR with conveyor will bring, in the first case, the empty boxes to the machines. Via also a Karakuri Kaizen system, 3 boxes are loaded on the MIR and the 4th box is stopped. You can also see it here in the movie. The delivery of these boxes, these empty boxes, is simulated in our lab with a pipe and joint rack. This is the interface of the MIR. The accurate positioning of the MIR is done with V marks, like you can see here. And under the improving IFS, but that's of course not necessary. The transport of full boxes is then copy-paste with the empty boxes. But of course, the interaction between both systems is very important. And you can see it clearly here. If both AMRs detect an obstacle, each other in this case, the wheel will stop and the MIR will calculate a new path around the wheel. We have chosen for safety reasons to stop the wheel because this is the biggest AMR with the highest weight. And when the path is free, he drives further. Okay, next step is of course the integration of this demo at the production floor at Altachem. For the results, we want to implement that the next 2 months this summer. And for the results, we hope we can invite you on the 30th of September. But of course, depending on the Corona guidelines at that time. And now I will give the floor to Joris. He will tell you more about the Flagstone orchestration software.
Thank you, Peter. Let me try to take over the screen. One moment, please. So my name is Joris de Sutter. I'm a project manager at Flagstone. And like the previous speakers already told you, Flagstone is the partner in this project, Trinity project, responsible for the software part of this project. By software part, I mean the orchestration of both the AGVs and, of course, the manual labor that's also concerned in at the work floor at Altachem. So let me continue here. There we are. So who is Flagstone? We're a rather young company. We're 6 years old now, rather small even. We only work with 10 persons for the moment, but we have quite an extensive experience already in everything involved with MES, manufacturing execution system. So this is where we excel, and this is what we do as our main activity. In this, we always try to maintain a total integration with the production of our clients. So with the total integration, I mean, so we're not only looking for a perfect man-machine coexistence, but also very important in our view is that the backend, which is often neglected by other companies, we think that this Trinity, to use, of course, the title of the project itself here, the Trinity of a machine, man, and backend, it's very important. So in this shows that we're also the right partner, of course, at the right spot here to showcase this project for you. Our software and solutions are, of course, very innovative, which will become very clear when I will show the demonstrator that I prepared for you within a few minutes. And what will hopefully become very clear to everybody who's viewing is that we especially focus on a very user-friendly UI, because, like I already said, the man, it's of course a very specific that I put the man in the middle here. If software, and very specifically manufacturing execution system software, is not user-friendly, we think that there is no real return on investment in a real production environment. I have a few topics to discuss with you, but the main focus will, of course, be on the demonstration, which will be a short video where we will show the software in use during the demonstrating itself, a bit like what Peter already showed you in his videos just previously now. So let's recapitulate a little bit on the two main goals for this project. So what we wanted to do with this project in total, not only Flagstone, but all the partners in this project, was to increase the overall production and efficiency of the production at Altachem. And once again, very important, we want to integrate both the manual and the automated part of this production. The automated part, of course, with the AGVs and the orchestration that's needed to have those robots do what they have to do when an order is passed onto the production floor. And also the manual part, very important, the operators, the real persons who are on the work floor, who oversee the production floor and who pass on the orders to the system, and of course want to be able to do their job in the most efficient way. What we also wanted to do, of course, is to add flexibility to the logistical process by making those procedures more agile, because I think it will already became very clear in what Laurens and Peter told you, that in the future, the purpose that the production floor at Altachem, it can change in the future. Machines can be added, different parts perhaps need to be followed for whatever reason. And then, of course, it's very important that the logistical software that we provide here is able to be very easily adapted to those new changing situations. So how did we tackle this? First of all, of course, we needed to be sure that we could provide an open collaboration and communication with those different types and brands of AGV. So Peter already told you about the MIR AGV and the Vivo AGV, but Laurens already told you that they already have at Altachem a Mabo AGV. To fetch the full boxes with components from the warehouse and bring them to the preparation zone. So the Vivo is for the components from the preparation zone to the machines, the assembly machines, and then the MIR to bring the empty and the full boxes from the machines to the palletizing of the work floor. So we are here with the problem that we have three different brands, three different AGVs, and also, of course, three different fleet management systems of those AGVs. Peter showed you already the difference between the software needed to guide the Vivo and the MIR. Of course, the Mabo, that's already a third one. And what we have to do with our software, our manufacturing execution system software, is to be able to orchestrate all those trees. And when an order is passed, that the correct instructions are given to the AGV so that they indeed do what they are expected to do, and that we get, of course, also status updates back from the AGVs so that we can continue with the correct production on the shop floor. So this is all in this digital steering and discrete orchestration that we tackled this problem. And of course, what's also important is that our software, like I said, has to be user-friendly. You see already a small screenshot here. So what we aim for is to streamline the integration of manual labor and those robotics. So our manufacturing execution system has tackled the complexity of 2 different workstations. So I mean, by 2 different workstations that you have the 2 assembly machines, and there is the preparation zone. So the assembly machines and the preparation zone, 2 different workstations. They have very different workflows, of course, but they are dependent on each other. So if an order is passed on one of those workstations, this influences what happens on the other workstation. Those 3 different AGVs who provide the internal transports, they have to work together, of course, in combination with the manual operators. And how we did this, what did we do to make it so a modular backend solution, allowing those easy changes, like I said, if changes in the logistical process are in fact needed in the future. So the solution for this is what we call smart manufacturing. And to show you what we did, I have prepared a small movie, which I will try to start now. And I guess that sorting it is the most easy thing to do now. And please enjoy.
There are 2 machines in the production hall that need to be supplied by parts. They are named here Line 1 and Line 2. The 3rd block shown here, a bit apart from the lines, represents the preparation zone. This is where the parts for the machines are prepared from the warehouse, hence the W. For the purpose of this short demo, I will switch between 2 browsers. The first one is the screen seen by the operator at the machine Line 1. The second screen is the one seen by the operator of the preparation zone. Let's start at the machine. The operator of Line 1 is logged in and selects his machine. Now he wants to see what is planned for today. There is just one order present in his production queue, a white tilting valve. The order is already in production for the moment. The order detail shows the operator the necessary details and control buttons. At the top is the progression bar. We're now at 60 boxes, finished on a total of 690. At the bottom is the bill of material, and it shows the available quantity at the machine of the 3 different parts which the machine needs to be able to produce the end product. Let's suppose that the operator notices that one part needs a refill. He then pushes the Request Parts button. There, the operator selects the correct part and the number of boxes he wishes to receive. This will generate a new order for the preparation zone. Switching to the screen of the operator who mans the preparation zone, we see the order arrival for those parts. The preparation operator then opens that order and has a view of the order details. He sees that 2 boxes are requested for that specific part. He also sees that the AGV Mabo is idle for the moment. That's the AGV that brings refill boxes from the warehouse to the preparation zone. The operator should still have plenty of available refill boxes at the preparation zone. He also notices that the AGV Vivo is still moving. It is that same AGV that will collect the parts from the preparation zone and bring them to Line 1. He clicks the Plans button and starts the order. Now, the operator will take 2 refill boxes from the stack and starts filling the tray for the Vivo. There are 2 trays, one in transit on the AGV and one in the preparation zone, which the AGV will alternately take away. For every box the operator fills, he clicks the New Booking button in order not to lose count. The last box has an extra Call Pickup caption. This will call for the AGV Vivo to come and get the filled tray. Returning to the Line 1 screen for the operator at that machine, he can now look at the workflow orders and will see there that the AGV Vivo is indeed on its way to deliver the requested parts. Here you can also see the history of recent workflows. Full cardboard boxes with finished products moved by AGV MIR to the palletizer, and a previous order for parts. When consulting the dashboard, we notice that AGV Vivo is indeed now moving to L1B1. Now, how does this look in the backend of the software system? This project has been developed using the open source software Node-RED. This is a programming tool for wiring together hardware devices, APIs, and online services, using a wide range of nodes that can be deployed to its runtime in a single click. When a workflow starts, the needed parameters are gathered and stored in the database to be able to visualize them. Remember the previously shown workflow screen. Now, the diverse actions are as follows. A pickup flow for full boxes of finished products starts an AGV MIR transport. A replenishment of empty boxes to the machine also starts an AGV MIR transport. A replenishment order for parts will first start an AGV MABO transport to collect the parts from the warehouse to deliver them to the preparation zone. This, in turn, prepares the prep order, and when that has finished, it starts an AGV Vivo transport to get the parts from the preparation zone to the machine. By visualizing the flow in this wire diagram, the development of the project was allowed a much better overview and unsurpassed flexibility. This allows all of our staff to easily chip into this project, even without much preliminary knowledge. And this results in a great advantage for our company in easily pinpointing nodes in the flow that need adjustment or bug fixing. But also a great advantage for the partners in the project, who can rest assured that our reaction time is greatly reduced when changes need to be applied. Everybody knows how rigid logistical processes can be in real life. Our manufacturing execution system software solution makes any adjustment much more flexible. We hope to demonstrate here that we succeeded in orchestrating different AGV devices and manufacturers to streamline the automation of the production process, while still always taking the human factor into account. This by providing user-friendly interface screens and integrating human labor with robotics by visualizing them together.
There you have it. So I hope the video was quite clear in what we tried to do within this project. So let me continue with just a few takeaways, which we think are the most important ones for the work that we have done. So we succeeded in a simple orchestration with different types and brands of AGV. We made sure that there is a flexible and agile adjustment possible for the logistical processes now and of course also in the future. And by using our user-friendly software, we guarantee the streamlined integration between manual operator and the robotics of the AGVs. So I thank you for your attention, and I would like to give the word back to Stijn to conclude this webinar.
Thank you, Joris, and also thank you to all the other speakers for your contribution today. There is only one thing that I wanted to show is what are the next steps, what is upcoming. Of course, we have been mentioning it already a couple of times. We are aiming for the 30th of September to move what we have made today to the real production environment of Altachem. We are aiming to have an open door that day so that you can come and visit and see in reality how it will work on the production floor. Just a couple of other dates. In October, we are organizing at Sirris a masterclass in production digitization, which is a more broader topic than what we are covering today. In March next year, we are organizing a masterclass about mobile robots. So really, this topic it will be about. And last but not least, We are running for the time being an online survey on flexible internal logistics, and I wouldn't be surprised if one of the coming days you would get an invite to participate in this online survey. So then also you know where this is coming from. So that wraps up our story. It is time for you now. I would like to ask you, if you have any questions, switch on your camera, unmute, of course, and then we can start talking. To organize this a little bit, I also ask you to use the hands, and then I will give you the word. So please shoot with your questions. In the meantime, we can already look at some questions from the chat. I want to stop sharing. And instead, I switched off my camera. So I also asked my colleagues, do we still see any questions that are unanswered in the chat? I can see there are a lot of questions, but I also can see that there are a lot of answers. I see Mr. Laga had a question.
Yes,
Go ahead.
I think it's a quite complex solution for maybe something that could be solved by conveyors. Why wasn't conveying not considered?
Yeah, it has been considered, but I let Lawrence maybe answer this question because he's the one.
Conveyors have been considered, but since we're also thinking about expanding and having more machines in the future, it still could be an issue. We are really looking to grow our production hall, and then still, if we need to look at putting vacuum lifters everywhere and still continue working decentralized, yeah, it would still give us some hurdles.
Okay. Right, fair. And maybe just one tip, there are machines putting bags in boxes, huh? and closing them and shaking them. You don't need personnel for that.
That's why we're going to integrate the box closing in the demo as well.
Okay.
Thank you.
But only one box closer for all the machines,
yes,
instead of 3 of them. Yeah. I see a hand of Mr. Ali. So please go ahead.
Yes, yeah, I just have a question regarding the orchestration layer of, because I saw that you said in the presentation that the different brands of AGVs or AMRs can be integrated with the orchestration layer. My question is more like, is it something based on a standard specification like a VDA 5050 or something, or how many brands of AGVs can be integrated straight away, or how much development it's required, let's say if we want to plug in a new brand of AGV or something?
Joris, can you pick this question?
I hope so. Of course, I'm a project manager, so I'm not a developer of our company. So I have just a very superficial knowledge of how everything was tackled by our development team. But in any case, it all depends, of course, on the fleet management system provided by the brands of the AGV that you want to integrate. Normally, if it's a good brand, of course, they should have very good software provided to guide their vehicles with the right APIs for us to be able to connect with them and to exchange the orders and the information needed for our software to be able to do all the jobs that are necessary. I guess that you also asked for the number of maximum number of AGVs, if I'm not mistaken.
Like different brands, how many different brands can be, let's say, are you working with now? I saw 2, but is there?
Three, in fact. So we had
Okay.
Mabo, Weibo, and Mir already,
Yeah.
3, and shouldn't be any problem at all to add a few.
Wait, I don't hear Joris any longer.
Can this
Okay.
happen?
We missed the last 10 seconds of your answer, Joris.
Oh, sorry. It says here, do you hear me now?
Yes.
Okay, so what I was saying about the number of AGVs, so we're now in this project, we already have 3 different brands working together with our software. It all depends, of course, how many brands you have in your specific factory, but it would highly surprise me if you have, let's say, more than 5 different brands in your factory, but even that shouldn't be a problem. Let's say even up to 10, 20. It all depends on the software and the APIs that the AGV brand can put forward. It all depends on that.
All right. Thank you, Joris.
But perhaps I can add something as well. The communication has now been done via REST API for each of the branches. What you mentioned there, the VDA 50/50 standard that comes out, is something that we will definitely look at to see, because now it's really specific for each branch. It has its own REST API description, and so the orchestration software had adapted to the existing API. But we will we are aware of the VDA 50/50 and see how it can be used, or because it's rather new, how it can be used, and see if manufacturers of AGVs adapt that or provide any ways but if the manufacturer of the AMRs of the AGVs provide it, then it's definitely a way to go to implement that as well. Just as an addition to what you said.
Yeah, thank you everybody.
Also linked to this, I see the question of Janis Huibrechts in the chat about the deadlock avoidance. Indeed, you did see in the movie that the Mir did drive around the Weibo. That's because it's programmed for it and it's able to do that. If this would be the case for the Weibo and the Mabo, for instance, that would not work for the time being. And in this case, there is no problem because the Mabo brings the pallets from the warehouse to the preparation zone, and the Weibo is located totally elsewhere, so they are not in each other's zone, let's say. But if that would be the case, you should think about the solution to that. Yeah.
Okay, thank you. So we paid special attention to that currently, so that the routes, the paths of both AGVs did not have a common area where they could be in a deadlock. So we took, it's not by chance it's like that, but as you will see it in September, hopefully you are there then, but as you will see, we made it that way that the parts of the AGVs who cannot calculate a new route have not a common area where they can cross each other in a certain point of time.
Okay. Yeah, thank you.
Okay. I ask again the help of my colleagues whether there are any unanswered questions in the chat, or if there are still people who want to ask a question verbally. And if not, we can end this online session 100%. I see Mr. Laga has still a question.
I still am a little bit at my hunger about AGVs and AMRs maneuvering between ambient and cold stores. Because I can imagine it should happen. It should happen a lot of times in food industry, packed fish, packed bread, whatever. And once they are packed in an ambient environment, you have to bring them as soon as possible in the cold store to avoid defrost.
But I believe my colleague Philip has answered you that we can pick this up separately. because it's a very specific question also.
I'm already looking 1 month for such a solution and everybody declines.
Yeah, but that is maybe the problem. Okay. If there are no more other questions, I think we can close. And I would like to thank you all for your presence and your interest again. And thank you also to the speakers.
Thank you. Bye.